Hey everyone, welcome back to the podcast. Today we're talking about a very interesting subject. It's based on a handbook that we're working on called the Contrarian Handbook of Software Development. And we really talk about why software projects and a lot of other projects don't in general work, and why current management philosophies, including delegate and give people a lot of freedom, don't actually work in practice. I think you'll find this very interesting and very applicable to your company. I'm joined, as usual, by Josef and Igor. We will all introduce ourselves very briefly for those of you who are new. Josef, would you like to begin?
Hi, I'm Josef, founder and CEO of Prodigipa. We're doing enterprise implementation and AI stuff mostly in Germany. And I've been in IT for about 30 years, so I think I've seen the occasional project fly by. Thank you.
Awesome. And Igor?
Hi, my name is Igor. I am co-founder of Corsac Technologies. We are a modernization and software development company. I've been in IT professionally for about 13 years, and I managed personally several dozens of projects from launch to ideation to design to development and to launch and further maintenance.
Perfect. Hi, I'm Sheikh. I have a background in the AI space. I've also led teams in Deloitte and in other places, most recently at my own company. And these are really some insights that I've been drawn from some of the learnings that have been happening for me personally in the area of the theory of constraints, which really focuses on how organizations can be a lot more productive. And the recent black belt certification I've obtained in Lean Six Sigma. And I distilled these insights into what I see going wrong in software and technical projects in particular. And so we'll be talking about some of these, and down the road you will see a version of the handbook that you will be able to access that started this subject for us today. But we wanted to shed light on what typically goes wrong in these projects in terms of what individual contributors are doing. And Igor, I think you had some insights that you would like to share about that.
I would like to start this topic not with the technical questions, not with the technical question, not with people management question, but with a question of initiatives. A big chunk of problems in software development projects comes from initiatives of different roles, how they do their job, what they do, why they do their job, and how they feel useful. As Josef mentioned in our previous conversation, that there are lots of other sources, but I will particularly start with this one. And if to frame it easily, lots of problems come when software developers try to make more code because they're software developers, they need to make code. Project managers need to write tasks because they're project managers. Designers need to design, and HR needs to HR. Especially in startups, especially first-time startups, like the most common type of startup, people do not recognize those problems, and people who work on the project. I mean also people who manage the startup itself. So the founders of the startups, they may not recognize those problems, and this is where they spend most of their time and efforts. And this is one of the big reasons why they might fail, because the initiatives that they set in their company are simply set wrong. And I believe that that can be the start of our discussion.
Yeah, I think that's a great starting point, and I can relate this to some of the broader concepts. But Igor, would you like to elaborate more on this? Because I think it's very, very interesting for you to talk about like the actual way in which this would happen in a project, like what you've seen.
Let's try to give a live example. You have a team of 3 developers. let's say you have a backend developer, you have a front-end developer, and you have some other, let's say you have another front-end developer, and you're building a web platform. When planning their work, obviously the developers are trying, and the project manager who works with them, they're trying to fill all their hours with productive work. For the developer, whose main job is to write code, productive work is writing code. In some companies, the developers are actually they get bonuses for the amount of code that they write. And in some companies they don't. And when you have an initiative of writing more code, you start writing more code. And when the project manager has an initiative to describe all the tasks in a very precise, peculiar manner with maximum details, that's exactly what they're going to do. And the problem here is that though that code, those tasks, those designs, they may not really align with the company goals, and they may not really align with whatever the company wants to achieve. As human beings, we often measure our success by the efforts that we're taking, right? So we think that if we did all this big chunk of work, that we did well. But when we actually measure the result of that work, it may say us something different. And a very common problem that startups do not do is they do not measure the outcomes of the decision which they realize in the code, in their products. Let's say you want to create a feature, right? For the question number one is, why do you want to create a feature? You want to create a feature because you have a good vision. Let's say you have a visionary CEO, right? And that CEO sets the stage for first version for some time of whatever development of the product. The developers are happy about it. Software managers are happy about it. They describe the tasks, they write the code, they deliver the feature to the users, and then they need to understand how this feature is actually doing. And this is where things get a little shady. Very often, companies like startups, which are working on their product, they try to develop only features efficiently without spending any time, for example, for introducing KPIs. You don't introduce the KPIs, you don't understand how the feature is doing. You don't introduce the analytics, you don't know how users are perceiving the features. You don't communicate with your users, you don't really know what you're doing with the product, essentially. So the problem is that developers are measuring their work by code, managers measuring their work by text, essentially, or making meetings. And the CEO, looking at all this work, may have a feeling that, look, we're doing so much work, everything looks so good, but let's say we don't see the results. But what they're not doing is they're not measuring the outcome, they're not communicating with the users, they don't know how their users actually perceive their feature. That's the number one. There is a very good book about this called The Lean Startup.
Yes.
Yeah, that's basically what they're writing about. Another point is that over engineering, with I'm sure Josef can speak more about a bit later. I will just set the stage for it. Developers may be very motivated to introduce something into the systems. They may be willing to introduce something even in their own time and just creating it like, look, I did all this cool work for the project. But what it creates is it creates, first of all, more complexity, again, as you, Sheikh, mentioned it in one of our previous conversations. And it creates more maintenance costs in the future, and it does not make things easier for communication with the final users, because now you have more features to verify. essentially.
Exactly.
That's thing number one. Thing number two is that startups are often not lean with actually features that they're introducing, and they're over engineering and making things more complicated. And they find it then, coming back to the first point, they find it difficult to measure the results, and that way they're spending lots and lots of money on development, design, and project management, which does not really have a final goal. Something like that.
I 100% agree. I want to put this into a broader framework. So I think so. I'm going to put it into Goldratt's framework. He's the guy who came up with theory of constraints. A really, really interesting guy. And essentially, he said the first thing you have to define in a business is your objective. What is the goal of a business? Now, the goal of a business is to make money, right? At the end of the day. But when you talk about making money, like every activity in the business should have some correlation to either making money or with a concrete potential to make money. Not a broad hypothetical, not doing things for the sake of doing them. Really showing that this is actually going to lead to more money now or in the future, right? So we want to make more money. Okay, to make money, we are doing a product or we're providing a service to the market, right? That's obvious. Now, if you're doing a product or providing service to the market, you have to focus on the things the market is willing to pay for, because that's how you're going to make money, right? So everything in your product set or service set has to be fulfilled to the market needs. They have to be specified by the market. A lot of startups who are pre-product market fit haven't even found the problem that the market is willing to pay money for, right? And when they're over engineering at that stage, which is a very common thing, what tends to happen is they're introducing all of this stuff that nobody's going to pay for, but which hides away but which prevents them from actually solving the core problem, which often has not even been defined. So the first thing to do is to say, okay, we want to make money. The second thing is we have to define a core problem that people are willing to pay us for. The third thing you need to do is to build something simple, right, and test it in the market to see, is the market willing to pay for it, right? And once you have built that solution, then you want to keep it lean. It's not just about building it lean, it's also about keeping it lean. Why? Because when you have built something, it appears that if I do something at the local level, like I add a little bit more features at one part of the stack, right? Like I make the UI a little bit fancier, right? Or I make the backend a little bit more sophisticated, or I put a couple more endpoints in the API, okay? That brings several problems. The first problem it brings is everything has to integrate with everything else, okay? So you have a multiplicative effect in terms of additional complexity. You have an upstream and downstream multiplicative effect. That is an immediate cost to the rest of the pipeline, right? Because at each local stage, you're trying to optimize it. Instead of doing 80-20, you're saying, let's do 90-10, let's do 95-5. The problem is for that additional 10, additional 5, additional 2-3%, the added complexity is a lot, okay? And that has a negative effect on the rest of it. So complexity typically costs money from that perspective. The other way it costs money, which you talked about, Igor, is it costs money because you have to maintain it for all time, right? So anything that's more complex is A, harder to understand, B, harder to interface with, and C, harder to maintain, and as an end result, more fragile. When we're moving in a direction in the world where things are moving faster, not slower, software is being changed and written faster, not slower, vibe coding is taking up more and more of coding. The transition is not to more features, but actually to more simplicity, and to focus on solving core problems, and to be more agile and to be more adaptable. And when startups and bigger companies are running with these metrics of activity-based rewards, and unless you're doing enough activity, you're not going to be rewarded, people are not really incentivized to simplify. And people's idea of a good job is also wrong. People's idea of a good job is how much effort they put in, how busy they were. This is how companies often are measuring themselves. But when you did a good job, it's what is the least amount of effort with which that task was solved in terms of lines of code, in terms of complexity of design. It might take you 10 days to come up with 50 lines of code, but if you can do it in 50 lines of code instead of 5,000, that is way better, because you're saving an indefinite amount of time and future complexity. And again, if you're measuring man hours, one developer puts in 10 days of effort. Okay, that's like 10 days of man hours for one person. But across the whole organization, you might be saving 1,000 man hours, 10,000 man hours, especially if you take the timeline into the future. So these local optimizations and these activity-based measurements create huge problems. And Goldratt identified this in manufacturing first. But this is a global problem, especially in the software space, and I think it's much less well understood in software. So I think that's something we want to talk about today. I've gone on for a bit. Josef, did you have anything you wanted to say?
There is one thing that strikes me about the entire perspective that we have on the topic so far. Igor started his example with, let's assume we have a team of 3. I think we had 2 backend developers and a front-end developer, or it was the other way around. You said, well, let's assume we have a team of 5. Now let's look into vibe coding. With vibe coding, we have a team of 1 plus an AI coder. And now something funny happens, because if we have, in Igor's example, 2 front-end developers and a back-end developer, and now for the best out of the best of intentions, somebody says, I need this new front-end feature. Dear back-end developer, there is nothing that you need to do. Something weird happens. The guy, I mean, that is human. That is human nature. He feels I have to do something, because otherwise my feeling of self-worth goes down the drain.
Yeah.
So he does something. And that is one of the sources of complexity that we're currently zooming in on. 2 weeks later, the same thing may happen the other way around. We need, for example, a new database features. Dear front-end developers, what do we do with you in the meantime? So these 2 guys have to do something more or less meaningful just because they happen to be there. And now we go back to the example of one guy and an AI coder. And our guy says to the AI coder, you know what? You're really, really good at backend development, but I'm simply not giving you a prompt because now I need a front-end development, and the other AI coder is good at front-end development. And what does the AI coder do in that moment? Nothing. And I wonder whether the entire productivity boost of AI coding and vibe coding is just from the effect that people do not, that an AI coder does not do anything unless explicitly asked. But then again, they do a lot of weird stuff when they are explicitly asked, so that probably cancels out.
No, but that's a good point. I think that's like, we don't measure machines in terms of hours of use. We measure them in like we don't measure AI by how much, like, it costs us money to use it, right? It's a fractional hire. So we measure it really in terms of like, when did I use, like, I only used it. So this is the biggest problem with hiring people full time, is you have to get them to do something, otherwise you feel dumb. With AI, you don't have this problem.
There is, if you go into the discipline of Scrum, and if you look into how Scrum works, and also the SAFe scaled agile framework, or whatever the name was, how you can take up Scrum to larger teams than teams of 10, like for example 100 or something like that. There is an entire piece of art, or an entire work field in these frameworks that is about making sure that everybody has something meaningful to do while the team is running. That is why the SAFe people have the idea of a release train. So you build one release of the thing, and while you certify that for shipping it to the customer, you can branch off the development team and start working with them on the next release. That is one of the big things that I've seen particularly in very, very, very large organizations. You reach the point of time, the end of a development phase, and then the testing starts. And at the moment when testing starts, you run into a really difficult problem, because in the extreme case, you suddenly tell 2,000 people, stop doing whatever you're doing. And it never works. I mean, you may reach, for example, 2,500 out of 3,000, but the remaining 500 can still create a lot of confusion. And it's all in the best of intentions. Both the people who say, please stop whatever you're doing, and the people who violate that order have the best of intentions. And if you look at, one way to think about Scrum is to say, we started with a release cycle of a year. And then we had that funny stop problem. So he shortened the release cycle to make that problem smaller, so that the test phase is smaller and the stop phase is smaller. And eventually you arrive at a typical Scrum cycles of 1, 2, 3, 4 weeks. And then the stop problem actually goes away if you get it right.
Yeah, so this is where I think this is going to be very interesting. Igor, I'd love to hear your perspective on this. So we have a few things that we've talked about. I think one is something Goldratt also talks about is getting people to do nothing. I think that's very important. When there's no work to do not do work, or do like learn things that are going to improve your skill set, right? Or build assets that simplify and speed up our builds. Don't like focus on simplifying and reduce. So one is, I think the core idea in most people's heads is the more I do, the better it is. And the question is, if you can figure out how to do less while having the same impact, like you can focus on simplicity and less and get the core things to work well, that's already better. But the broader thing here, which I want to identify, this is the big problem I see in software development. So there's traditional waterfall development, which is a very planned, detailed, meticulous development process. Now, that was criticized by people in software development because they said it doesn't deal with the realities of software. And they came up with Agile, right? That's kind of the main, and the Scrum, the Kanban system. So these are kind of the main sorts of innovations in how to do technical development. The problem with all of these methodologies, which are based on fast iterations and user feedback, is that the user then starts to steer the ship. Okay, because there's no cohesive overarching plan, and you're very guided by user feedback, and you're very much trying to make the user happy. And the problem this creates is that the users keep demanding features. And sometimes the feature is already built, they just didn't know how to use it, so they demand it be built in a different way, so they're a different set of users who can now use this feature that's already existing. So the problem it creates is if you do very planned development, that has big problems because there's unexpected complexities and there's unexpected simplicities that are going to arise. And there's a lot of chaos and change in software development. It's not so friendly to time-based estimations, okay? Because the problems are not time dimensional. It doesn't take time to solve software problems. It really takes breakthrough solutions in the idea space. It's just code is just ideas. So it's not putting a time is hard. Okay. But then Agile and Scrum, which are very focused on let's build things that the users want, very guided by user feedback. There is not a framework for how to make a decision on what user features to prioritize. And then also how to go from this scrappy iterative cycle to a more cohesive, stable approach that's going to stay. Josef, do you feel like I've identified a correct problem in the development processes, or is there a solution to this I don't know about?
I think what you're talking about is definitely a significant part of the challenge of developing software and software products. And it is, by the way, a very different problem when you look at company internal IT departments that develop a tool that is supposed to work for one company. Inside of that one company, identifying what the piece is that adds most value is reasonably simple. When you look into software product development, pieces of software that are supposed to work in hundreds of different environments, identifying the next most valuable piece becomes a ton harder. And the best that, as far as I know, that community has come up with in order to solve that problem is on the engineering side, the concept of a Scrum product owner. That is the person. It is not a concept. It is not a process. It is not a methodology. It is a person who has to have the skill and the competence to take these decisions and to take good decisions about that. And I know a lot of Scrum product owners, and I know very few who are really good at precisely this thing, identifying the next most valuable thing, particularly with the complexity aspects of it in mind. And when you look beyond software, core software engineering, and you look outside of that and you think about how do you turn a piece of, how do you wrap a piece of software into a product? It's a very different challenge. Then the best answer I have on that is what is it called? User-centric design. It's at the tip of my tongue. the methodology that was developed by Frog Design when they were asked to come up with the design of the iPhone. That is the best way how to come up with the features that you need. And then a significant chunk of the challenge is then you have the product design people who go out and do user testing and ideation and all these things. And you have a software development team on the other side, and you need to synchronize them.
Yeah.
You need to get cool ideas, next most valuable things, one at a time at ideally exactly the same pace as the software engineering team can deliver them. And to be honest, if you really get that right, it is for about 3 weeks in a year, and it is a huge coincidence. There is no systematic way of doing that. So there are things like backlogs, or you could call it pipelines as well, that help you with manage that's difference in velocity. But it is something that you have to live with, and it's a problem that you have to solve on the management level.
Yeah, what we're talking now, essentially, is that the problem of software development is when you are developing a product is predominantly not a technical problem. It's a problem of people management.
Yeah.
And the company will need to absorb lots of those problems. And the most difficult learning curve is specifically about people management and time management and priority management, rather than solving a certain technical problem, with a rare exception. Of course, there are some technological companies which are solving a very difficult technical problem, but we're not speaking about that. We're more speaking about mainstream software product development, where most of the stuff is already invented, essentially. Now you need to tackle the business problem and create a solution for that out of pretty much developed pieces of code, or developed other products, or developed other approaches which already exist. And if to go back to, I want to make one more comment regarding user-centric design and user-led, or let's call it user-led organizations, when the users are asking about features, and the company tries to create those features to satisfy their users. That is a very tricky thing to do. I've seen, again, I'm more on the development side, so I do not usually maintain communication with the users. I organize the process of development. But what I've seen with my clients a lot is that they try to satisfy every user, and it seems to be a reasonable thing to do, because if you make your users happy, they buy your product. Again, sounds like a reasonable thing to do. The problem with that is users are not always telling you what they actually need, what they actually want, and what the problem is. Somebody can tell you to create a button there which performs a certain functions, and then the product owner sees that, tells the project manager to describe it as a feature, and the development team runs and does it next sprint. But nobody actually knows what specific business problem it solves. Is it in the general vision of the project, and will it actually be useful for other users? And this way you usually end up with a product where 95% of features are used 1% of time. And this takes us back to the beginning of the discussion with over-engineering, when we have so many other unnecessary features, and the maintenance of the application is so freaking difficult that you waste most of your time and budget and need to hire additional people just to keep this Leviathan alive. Because if you don't, everything falls apart. And rewriting it or remaking something looks so scary that modernization projects, which is my domain, are just like, people are afraid of them. People don't want them to happen. And people think this is something that will take years. And that's why you have this weird status quo when everyone knows that there is a problem, everyone sees the problem, everyone knows that the problem is complexity, but nobody wants to get rid of that complexity, because this is what their jobs are actually doing, essentially, maintaining that complexity.
It's not quite fair. But
It's not fair. Let me. The problem is that at the beginning, Sheikh says that everything needs to be done for the business, right? But what we're talking now is not done for the business at all. Like the problem,
that is true.
The problem of this huge Leviathan product, which has most of the features redundant, is actually the problem of wrong feature prioritization, wrong incentives for developers, and basically all the roles, and the status quo which everyone wants to maintain, and the business pays for all this stuff. And since everyone kind of maintains this status quo, getting out of it is actually very, very difficult. And I've seen many modernization projects fail because of that. If you start working with their team, you start trying to tackle the problem, you start trying to understand something, and the inertia of the system is so huge, you cannot really do anything. That happens.
That's true often in most big companies in general.
Yeah, that's true in most big companies, exactly. And that's why some big products of the big companies can be created by a smaller team in a small fracture of time that the big company spends on it, simply because they may do it more efficiently.
Absolutely. And the Pareto principle, the power law stuff, that's super important. So there's a few things, like you're saying. I think, look, here's the main thesis. I'm like, my goal is to try to help companies and businesses fix some of this stuff because it is fixable. But there is a bigger thesis that I'm positioning, which is that I think big companies are going to go extinct, right? I think business follows the laws of evolution, the marketplace, right? And I think big companies, there are certain laws. So big companies really arose during the Industrial Revolution, where you had huge economies of scale when you set up big factories and big production lines, right? And that's been the case. And, even for software and stuff, in many ways, big companies did have an advantage, right? Putting big software products together. But as the ratio of developer to code has improved, one developer can put out more good code, especially with AI, more higher level languages, better frameworks, a lot of things now that you don't have to set up your own server, right? You could use cloud. You don't have to set up your own cybersecurity. You don't have to set up your own. There's a lot of things you don't do yourself anymore because it just doesn't make any sense. So, setting up a website with hosting and stuff used to be quite a complex thing. Now it takes you can do it in 10, 20 seconds. So the reduction in, depending on the scope, but that transition to faster and more better tools which allow for more output per person requires that fewer persons will be working on these things. And I think big companies have a few inherent problems. One, which you talked about, Igor, is they're very hard to change. And it's a good thing to be resistant to change at certain scales. But they're not resistant to change on principled grounds. They're resistant to change because of political inertia. They're resistant to change because there are too many people in too many different directions. They're resistant to change because there's nobody who's able to push arguments through, right? They're resistant to change for a bunch of reasons that have nothing to do with maintaining the stability of the product in a way the market really cares about. So I think that the biggest story here is going to be that we're going to see bigger companies start to really struggle in the AI age. And I think we're going to start seeing that very, very soon. What are you guys' thoughts about that? Like, do you think that the ideas that we're talking about lead partly to the conclusion that big companies are going to struggle, or?
One thing that is that is really dear to my heart when you have conversations like that is a paper that has been written, I think, almost 50 years ago, that is called No Silver Bullet. And that basically says software engineering is hard. Every software engineering project has essential complexity, a complexity that results just from the problem itself. Never mind how you solve it. You give it to a bunch of monkeys. You set up a team of Nobel laureates. You give it to a computer. You give it to an AI. Never mind how you do it. This is an essential complexity of the problem, and it doesn't go away.
Okay.
And there is an accidental complexity, and that is the complexity that we add through the approach that we take.
Correct.
So, for example, if we try to write a piece of software in a waterfall method, we get a certain set of accidental complexity that is inherent to the waterfall method. And if we try to do the same problem in an agile method, then we get a certain set of complexity that is inherent to the agile methodology. Now, the essential complexity of software development is identifying the next most valuable feature. You can try to do that in the specification upfront so that you get around the problem of users getting you in a slalom. You can try to do it user-driven by looking at this is how far we come now what is and ask the user. But one way or another, if you have this essential complexity of identifying the most valuable problem, the next most valuable feature, and that simply doesn't go away. Now, if you go into the large company structures, their resilience to change is sometimes it's a good thing, sometimes it's a bad thing. If it comes out of inertia, it is a bad thing. If it comes out of understanding that this is not a fad that we have to run after, but instead we steer straight on, then it's a good thing. And that is a dimension that I would like to bring to the discussion. Is the thing that we see, is it a bug or a feature? It depends on where we are. It depends on what is going on. And without the context, it's going to be very hard.
Yeah, I think one more thing that I would like to encourage people to do is to put in a prioritization matrix. So it's not just what is the next most valuable feature, but there are also then trade-offs. How complex is that feature, right? How divergent is that feature from our current feature stack, right? Will that feature potentially create other feature requests that will then create a much more complex result, right? So we have to have a nuanced approach to decide. So one is, how do you identify / create / innovate new features that would be good if we built them? Okay. The second thing is, how do we select between them, right? And more importantly, which ones do we not do, right? And the not do, again, can be we delegate those features to another company, we build a separate product that is built separately, maintained separately, which provides those features, and our users get a shared login and maybe some data is shared, but they're two separate products. How do we actually conceptualize? And this is the problem, right? So either you can build the whole building first, like in waterfall, and then try to build, like, you have the blueprint, then you build the whole thing. The problem is software changes a lot. There's a lot of unknowns. That's kind of hard to do. The other way with Agile is you're like, let's just build this organically from the ground up as things arise. But then you get a very messy structure as well, right? Neither are optimal. They have different set of advantages and disadvantages. Overall, Agile is probably better. But even so, we really need to have a more systematic and solid way of doing this than Agile provides, I think. And I think in relation to individual contributors and how they see their roles, because in Agile, it's a lot of small teams having a lot of autonomy, which is great, right? But the problem with that is when people do not understand the costs of local actions they can take sufficiently. Like if they think, if I had an extra feature because I worked overtime, I didn't even bill those hours, I worked overtime for free, I'm not costing anybody any money. In fact, I'm going above and beyond. I spend my weekend doing this. What do you mean you guys don't want it? It works great. Some users want it. It's a great thing I've done. The problem is when you do that as an isolated person, you think you're doing a great job. But when you look at it in the context of the whole product, you're now adding a divergent direction, okay, that is going to have to be maintained, that's going to have to be integrated, that may lead to other divergent things, and which may not be something the customer ultimately cares about that much. So maybe some customers do, but not the majority. So I think that is so important and so not understood and not solved in terms of how do you get a team of exceptional people to do great work without and giving them autonomy, delegating and all, without sort of creating an environment where everybody's going in their own direction and you get a very Frankensteinian product. And this is talked about in Y Combinator. Paul Graham wrote a famous essay called called Founder Mode, based on Brian Chesky's talk, Brian Chesky being the CEO of Airbnb. And so Paul Graham wrote this essay, and they're trying to figure out what founder mode is. And he's like, you as a founder should be working with as many people from as many levels deep as possible, and make sure you're really involved in the product in all parts of it. Okay. And the question is, what is the principle that explains why founder mode works when it seems to go against most management thinking, which is you have different layers, you delegate responsibility, you don't micromanage, you give people freedom. So what is it that explains that founder mode works better than that? And doesn't founder mode seem kind of impossibly like you as a founder just have to do everything now, right? Is there a solution? And I think the solution is that there is a lack of organizational alignment amongst individuals in an organization. And the reason there's a lack of organizational alignment is because they're focused on their local parts of, I'm a designer, I'm a developer, I'm at this, I'm at this. And the more I do, the better it is for the company, especially if I'm not even, if I'm being more productive per unit time, I'm doing twice the amount of code lines that my colleague here is doing, and my code lines are just as dense as his are, I'm twice as good. But in fact, that's not how to look at it. The question is, are you doing that and only that which actually matters, and not adding more? So I think that's kind of, it's like the Statue of David, right? Like the Statue of David was carved by taking away whatever was not David.
Yeah, I wanted to add a little bit to what Josef was saying regarding the problem identification, and I wanted to make 2 points. I spoke about users giving feedback and companies following user feedback and doing exactly what the user asked. I did not. I want to make it clear. I did not mean that companies shouldn't do this. No, I mean that users are usually not very good at identifying the problem that they're facing, and that's why you need. That's why you need a experienced product owner who will look at all that user feedback, have some proper meaningful communication with the user, and will actually identify the problem with the user's face, and then the development, design, and whatever team will solve this problem, and then give it to the users, and they will provide feedback if they are happy enough. Essentially, that's point number 1. And point number 2, regarding making changes in the system, I specifically on technical side and making things more complicated. I had not even once, but I will give one example in my practice where so basically we had a very big project with Angular front end, like really, really, really big. We worked on it for like 3.5 years by that time, with a team of like 10 people, I believe. So it was pretty big product. I cannot explain all the details, obviously. And the client hires a front-end developer into his team that works with our team. And that guy writes in React. And what this guy is doing is saying, let's update our front end to React because it's a better supported technology, which sounds about right, because React is technically a better supported technology than Angular. But Angular at the time, it was completely fine. Like, there was no problem with Angular. Everything was completely fine, everything was working, and the entire system is built on Angular. And that guy starts to introduce features, pages in React. And now any front-end developer will run to the church right now. You understand what's going on there? Because what it created the absolute impossibility for us to properly coordinate
exactly
our
what we're
efforts, because
saying.
we were still developing React, and now he
irresolute freeze, like this caused a total freeze in
we could
team.
not influence
while Igor's coming back. I think this is kind of, I think we've all seen this plenty of times. I'm sure, Josef, in your ERP implementation project, you've seen some of this. Starting with companies don't even know why they're putting ERP in first. And then second is what features, because ERP has a lot of features, like, whether we're talking about SAP-like things or Odoo or any of these things, they have a lot of potential features. And and usually ERP projects are all delayed. Am I right?
There is a famous report, the chaos report, that is taking toll of software or IT, I think IT projects every year. And for as long as I've been watching it, it has a success rate, or it has a failure rate somewhere in the 80% range, 70%, 80%, 85%, something like that. They have a very, very, very strict definition of failure. So if you run over the schedule, for example, you have a project of 6 months and you have you run over by a month, it counts as a failure in that sense. And I think if you look at it from that perspective, then there is a huge gray zone of projects where the sponsor would say a year later, it actually was okay. But you have to have a definition somewhere. It was okay in the sense it went over time, it went over budget. But now that we are over the hump, it actually looks quite nice. So that is what I mean. But still, I mean, IT is a really tricky topic. And most particularly where I'm working these days with small companies who don't really understand their processes yet. In a way, they don't know what they're doing, but it works because they are smart people. When you start introducing software there, and you force them to think about processes, you force them to think about how do the bits and pieces in your company interact, how do they work together with software or without software, and how do you want that to change? The first answer you usually get is, well, we want to do everything in exactly the same way except different. Wait. We want to do everything in exactly the same way, except we want the computer to help us with it. Well, yeah, but if you don't want to change what you are doing, where is the step where the computer is going to help you? So you need to get into the mode of thinking about what is it that I want to and have to continue doing, because that is where the human adds value. And what is the piece where a computer adds value? Because I mean, let's put away the AI thinking for a moment. Humans are really, really, really good at creative stuff. We are good at inventing things. And traditional IP, database-driven IT, is really, really, really good at not inventing things and doing exactly the same thing 10 million times if you want to.
Right.
And so you need to start to think about where is the combination? Like, what is the stuff that a human does? What is the stuff that the IT does? And then if you apply that kind of thinking to IT itself, how do we do IT projects? You realize we started with assembler, we moved into C, we started to have compilers, we started with waterfall-based processes, we went on to Scrum-based processes. Now we have AI coders. But there was another really interesting report, I think it was 20 years ago, where they asked one of the gods of software development or software engineering processes, now that you have all these tools that you have today, what can you do with it? And he said, well, we'll do whatever people need, and then we'll reach the limits of manageable complexity, and we will invent new tools to handle the additional complexity that we need to handle to build the stuff that people are asking for once we have solved all the topics that we can solve with the tools that we have.
Yes.
And so the complexity of the systems that we build is growing because we're using complexity managing or complexity encapsulating tools, usually libraries. And the resulting complexity of having managed or having banished one level of complexity is more complexity. Again, there is essential complexity. There are problems that we can now start to solve that were completely out of reach 10 years ago. Look at AI, transformers, large language models, and that kind of stuff. We just couldn't have made it. We didn't have the tools for that.
Yeah, we didn't have the compute power either. Yeah.
Yeah. And there is accidental complexity. Now that we have these funky vibe coding code agents that help us glue together existing libraries in no time, nobody takes the time to really review the code, and the code that these AI coders generate often are unnecessary complex because they are just reusing coding patterns without understanding what the requirements for implementing these patterns were in the piece of software that they were trained on.
Yes,
And
I think that makes a lot of sense, and I like this idea that you've put forward of complexity, right? Where there's like, there's market demands. You build things get more complex over time, then you figure out a way to make them less complex. Maybe for more compute power requirements, like you find another trade-off with which you can trade off the complexity. Like we could all be writing in assembly if we wanted faster programs, but
Oh,
speed
hello.
is not as important. So Igor's back from his trip to the church. Igor, how are you doing?
I'm fine. I had a good prayer. The Lord heard me. Yeah. Uh, yeah, I'm sorry. Something was very, very wrong with my internet.
But you were about to finish your story about this Angular project where you had this person who
Yeah,
started
yeah.
putting in React.
Yeah. And so what happened is that part of the team started to work in React and part of the team started to work in Angular. We were trying to struggle against it, but it didn't really work out. So we just had to fly with it. That's it. Like we didn't have any insights. And if to look at this conceptually, and by the way, which meant that our productivity fell just like completely. We started to stopped releasing features in times and so on and so forth, just complete mayhem. And why did it happen? Because the problem which seemed to be solved with update to React was non-existent. There wasn't a problem to solve. Everything was fine. And this takes us back to the question about the inertia of the system, that yes, sometimes there is inertia of the system because people don't want to change, but sometimes, and again, I've seen those cases, there's inertia because things do not need to be changed. Things are actually going fine. And you need people, like you basically need people to understand when things are going fine and when there is no problem, or you need people to understand when there is a problem and it needs to be solved. So that's the point. Like we need to when we solve a problem, first of all we need to identify it properly, and second we actually need to make sure that the problem actually exists. Sometimes it doesn't.
I mean,
Okay,
there is the old
perfect.
IT saying, if it ain't broke, don't fix it.
Yeah, exactly. Exactly. Like this old saying about admin explaining to his son how the sun rises in the east every morning. You know this joke? No?
No.
No, well, no. Oh, well, it's a very. I'm from Ukraine. Maybe it's country specific. There is this joke that son, little boy, asks his dad, who is a system admin, "Daddy, how does the sun rise in the east every day?" And the daddy asks him, "Does it rise every day?" Yeah. Without exceptions. Yeah, without exceptions. Okay, don't touch it. It works. So that's the point.
But then again, there are more than enough IT systems
Yeah.
that exactly work because nobody touches them, nobody sneezes near them, nobody has a flu within the same country or on the same continent.
Yeah,
Because
yeah.
if the wind blows, the whole thing falls over.
Yes, yes.
Yeah.
That's why you need good professionals, so they could actually identify the problem, the real one.
Yeah. But I think the point here is that a lot of engineering is like engineers are actually very poor product people, generally speaking, because a good product person understands what the market needs, what the simplest solution that's going to work is, and then how to manage the complexity of that solution once it's actually in the market. If software developers, designers, even for lots of startups that hire and then are very led by technical people, it can create all sorts of problems. Like, of course, you want very technical people and you want them to drive a direction of the product, but only if they're able to also understand what the market needs, what the priorities are, and stuff. And getting into feature mania is death. Adding complexity is death for most companies. And I think these are incredibly challenging and unrealized concepts in the space of software development in particular. I don't know any software developers that get any training in this idea of complexity management when they're building. Yes, they learn how to write clean code and structured code and modularity and all these concepts to manage complexity from a technical standpoint. But they don't actually understand complexity from a feature and product prioritization standpoint, as far as I'm aware.
I think I'm glad that you added that, because actually the entire topic of software architecture is a topic of complexity management.
Yes.
So if we're trying to architect the system right, to match all the user's requirements, to match all the technical constraints, to match all the constraints that emerge from the software development process itself and maintenance and everything, the entire topic of architecture revolves around managing these complexities. The catch is, it's hard. So it doesn't just go away. If I may, honor my first boss from 30 years ago. I was young and I was enthusiastic, and I went to him and said, over time, I sent him a few emails with, I have an idea, I have a proposal, let's do the following and improve the following. And he said, and at one point he called me into his office and said, I want to talk with you about your proposals. And I said, I was really curious. And he said, okay, I've read your proposals, I've understood them. I see the problems that you're pointing at, and I agree that these are really problems. We should do something about it. And I agree that the proposals that you are making will address these problems, and actually they are remarkably good given your juniority. They're really, really good, and we're not going to do it. Because then he explained to me a number of reasons on each of the ones, and I mean, unfortunately, he knows his business. And then he said, eventually, management is about saying no. And I think that is an understanding of the profession of management that the entire management literature could write a book about or two.
Yeah. And I think management by software developers for software developers does not often have that understanding, especially for startups in that space. But even for bigger companies, there is often a lack of harmony between the technical side and the management. And a lot of the reason I wrote this handbook as a contrarian handbook of software is that most software developers I know are quite resentful of management saying no to them all the time, but they don't really understand why they're getting the no. And to me, this was a very simple and clear start to delineate why management says no to software developers.
Yeah.
And also designers and all sorts of implementation side people.
And maybe in that sense, it is really, really, really useful. The other thing is, one thing that I've observed is, I mean, it works, by the way, it cuts both ways. Software developers don't understand why managers say no to them, but in return, the managers don't understand why the software developers say we can't do it in that schedule either.
Yes.
Which points at the interesting situation that the managers see one facet of the world, call it customers, call it market, call it whatever, and the software developers see a different facet of the world. So in order to bring that together, we have to facilitate communication in a new way, and just to make that work. And even then, something interesting happens. So, excuse me.
Yeah.
That is that a manager may come to a new insight. For example, today in the morning, and even in the rare case that the same insight will pop up on the software developer's desk through different channels, it will be asynchronous. So we need to find a way to synchronize these discussions. Now, managers or the salespeople, the marketing people are out there talking to the customer, getting new input day in, day out. And software developers are tackling their engineering problems day in and day out. So they have very, very, very different sources of input. And we still need to make sure that they have at least a sufficient overlap of shared understanding of everything that makes up the product.
Exactly.
And then figuring out what the next most valuable feature is on the horizon.
So for me, this is what our group has specifically, that we're all people who have both a technical and a non-technical understanding, which is quite rare. But the second thing I want to say is that there has to be more of an answer than communication solves it, because the non-technical person does not have the expertise to evaluate what the technical person is telling them. And the technical person does not have an understanding of the business side well enough to really understand where the person is coming from. So to me, writing some of these principles is solving one side of that, is to help the developer better understand management, which I think is easier than helping managers understand technology, by the way. But I do think that this is, for me, this set of principles is the beginning of a framework for helping organizational alignment between technical and non-technical aspects. It's not even about teams. It's really about, there are two dimensions. There is the dimension of what is the business itself going to do, and then there is the idea of the implementation and is the how are we going to get there? How are we going to actually implement this strategy, right? And when the implementation side is given too much freedom and they don't understand the hidden assumptions of the strategies, they start to deviate from the strategy. And when the strategic side do not understand the implementation, that subtle tweaks in some of the sub goals of the strategy would create big implications in terms of like this would take 2 weeks and this would take 2 years and this is impossible kinds of differences in the way you've articulated. Until that's resolved, I think there's going to be a fundamental disharmony, especially as companies are getting more technical and more quantitative. So I think a bridging sort of manual, a bridging framework provides something that all of us do every day and something that would be highly valuable. But I also think that there is an evolution of business coming because of AI that makes it more important for this stuff to be understood.
Mm-hmm.
MIT published a report 2 weeks ago that 95% of AI implementations are producing zero ROI, right? So this is not a fictional.
It's like .com
problem.
crisis now. Like we're expecting stuff similar to .com crisis, essentially. It's funny that we came to basically we're coming to conclusion that the software product development issues are management issues, like basically people management issues, incentives and priorities issues, internal and client communication issues, and only after that technical. That's pretty much where we come into.
You can have a swim team of Olympic, you can have a team of Olympic rowers, right? But if they're rowing in different directions, it doesn't matter if they're Olympic rowers or 3-year-old kids. You're not going to get anywhere either way. The Olympic rowers will just be a lot more expensive.
Yeah. There is a book by Melissa Perry called Build Trap, and she gives an example of, by the way, a very cool exercise. Ask different people in the company what are the company goals for the next quarter. That's the best thing to ask, and you'll hear absolutely different and aligned answers. And what it will give you essentially as an understanding is that let's say you're the owner of the business, you have your vision and you have your goals, and you think that everyone shares them. Nobody even knows them. And all of them have absolutely different vision of where they're going, and that's why their efforts are always aligned to where they're going. So then you get that result.
Amazing.
Mm-hmm.
I think that was like a great place for us to start to conclude here today. So thank you both of you for joining us. I think we'll talk more about. We were also going to talk about some of the cybersecurity and risks that AI is creating. I think that's a very interesting subject as well, and in the context of organizations and alignment and stuff. I think we can create a framework for organizations of the future to align themselves around emerging technology, especially AI. I think that can become perhaps the emergent goal of this, of what we're trying to do here in terms of sharing some of these ideas. But thank you both of you for joining me today, and we'll have more very, very soon for everybody.
Yeah, thank you.
Thank you likewise. It was a really interesting discussion.